to the Fourier transform lecture series. In this video, I will discuss about the properties of Fourier transform. So there are many properties of Fourier transform. In this video, I will discuss few of them. Firstly, the linearity property, and as we have discussed in previous videos that Fourier transform actually transform the signal from time domain to frequency domain, and by this scenario, or by as like this presentation, we actually present the transformation as we can see that this is the time domain function or signal here, and this can be transformed into x1 omega. So x1 omega actually the Fourier transform of x1t. This is the time domain function, and this is the frequency domain function. So if we have the Fourier transform of x1t is x1 omega, and the Fourier transform of x2t is x2 omega, then linearity properties for Fourier transform say that you can transform the Fourier transform these type of scenario or this type of function or signal like that. That means if we have this transformation scenario, then if x1 is presented with the multiplication as like a x1t and b x2t, then we can separately transform each of the signal, like a x1t could be transformed as a x1 omega, and b x2t would be transformed as like b x2 omega. So this is the linearity property of Fourier transform. So basically I will request of you to write down each of the properties several times, so that it will after a while or after several performing several tasks, it would be very easier and convenient, as I think. So this is the linearity property, and in the second number I will discuss about the time shifting. Actually, as we have discussed in several lecture or in class, that there are some many properties in case of signaling and system, as I have discussed. In this lecture video, I am going to, and I am actually presenting the properties of Fourier transform. So time shifting actually suggests that if you have the Fourier transform of xt as in x omega, so you can transform the x of t minus t naught. That means if xt being shifted from t minus t naught, then the Fourier transform would be x omega multiplied by t to the power j omega t naught. That means if you have the Fourier transform of any signal or any function xt which is known to you as like x omega, then if you have to determine the Fourier transform of xt minus t naught, that means the time shifting of that signal, then you just need to multiply e to the power j omega t naught with the known Fourier transform of that signal. So in several videos which will be the next videos, I will discuss about, you basically will get the several examples. So another properties I am going to discuss. The third one is frequency shifting. So this property actually suggests that if you have the frequency, if you have the Fourier transform of xt as like xt x omega from xt, then if you have to determine the Fourier transform of any signal presented by that means if you have to determine xt multiplied by e to the power j omega naught t, and in this case you actually know the Fourier transform of xt which is x omega, then just after knowing the x omega, or as you know basically x omega, then just time shifting of omega minus omega naught. So actually basically where will you get omega naught? Just e to the power j omega naught t. This angular frequency will be replaced by the s omega minus omega naught. I think it would be very easier after having several examples in next videos. So the fourth one is time reversal. In case of three previous properties, also if you have the Fourier transform of any signal or functions, then if you have to determine the Fourier transform of x of minus t, if you compare those, then just after having or knowing the Fourier transform of x omega or xt from x omega, x omega from xt, then just you should put or you should replace the x omega to x of minus omega. Another one is time scaling. If you have a known transformation from xt to x omega, then if you have to determine the x of at, if you compare those, then just replace the x omega to x of omega divided by a and multiplied by 1 divided by mod of a. Here the important thing is that you need to place the magnitude of a. So another important properties of Fourier transform is differentiation. So if you have a known Fourier transformation from x2 to x omega, basically this would be your known Fourier transform, and if you have to determine the xt, that was, or if you see that actually this is the determinant of what should I say, if you have to determine the Fourier transform of that scenario, or xt is to be differentiated. So in this case, just multiply the x omega by j omega. So I am discussing the basic properties of Fourier transform, and I'm discussing very few of them. So basically you need to study more, and I only discussing those will be important and those will be helpful for next videos or next slides. Another important is the convolution. If you in these properties you need to have, or you need to perform two signals or two functions. If you have the Fourier transform of xt from x1t, x1 omega actually, and x2 omega from x2t, then if you need to convolute them, actually this is not a multiplication, you will get basically the convolution of two signals. As I have discussed what is the convolution in the signal system part of my lecture. You can check my lecture series of S&S. So here I discussed about convolution. So if you need to evaluate the convolution, then just and most important thing is you should have the Fourier transform of two of them. Then just after having the frequency domain or Fourier transformation of two signals, just multiply them, and after multiplication you will basically get the convolution of two signals in time domain. So in coming slides, one of this slide I will present where you can check that convolution will be performed. And the final one, which I am discussing, the multiplication. If you have the Fourier transform of x1t is given by x1 omega, and x2t in x2 omega in case of x2t. So if you need to, or if you have to determine the multiplication like x1t and x2t, if any signal basically present like the multiplication of two signals, then if you need to transform it to Fourier transform, then just after having the frequency domain of separately like x1 omega for x1t, x2 omega for x2t, basically after having the convolution of them, and multiplied by 1 by 2s pi basically gives you the multiplication of two signals. So these are the basics properties of Fourier transform.